A chatbot can hallucinate. An agent can change state. That's a different problem, and it's quietly become the most interesting infrastructure story in AI right now. Take a model with a real shell. Give it a browser session, a writable repo, and maybe an API key sitting in its environment. A mistake isn't a bad paragraph anymore. It's a command that ran. It's a file that changed. It's a pull request you now have to unwind. It's a network call that already left the machine. Same model, completely different failure mode. So the first serious infrastructure question around AI agents isn't really about smarter models. It's about the boundary around the model. And that boundary has a pretty boring name that keeps getting rediscovered. A sandbox. But I want to be careful with that word. If you hear sandbox and picture one magic box that makes an agent safe, you're going to miss what's actually happening. Containers are old. VMs are old. Browser isolation is old. Staging environments, audit logs, least privilege, all old. The new thing isn't the primitive. It's where the primitive sits in the product. For a chatbot, containment can be mostly invisible. The user doesn't care which container your inference runs in. For an agent, containment becomes the thing the user has to trust. Because the user is now indirectly authorizing actions on real systems, the mechanism underneath this is actually pretty clean once you stare at it. A model interprets a goal. A tool turns that language into action. The environment is where the real state lives. Files, browser sessions, repos, and services. A permission boundary decides what the agent is actually allowed to reach. And then there's the side effect, which is whatever's left over after the run. Maybe it's a changed file. Maybe it's a browser action or some command output. Maybe it's an API mutation. Maybe it's a leaked credential. Or maybe it's a trace you can go back and inspect later. That model to tool to environment to permission to side effect pipeline is what makes an agent operationally different from a chatbot. Wrong answer versus wrong action. You can see this showing up in the product surfaces if you look at where the serious players are pushing. OpenAI frames Codex as a cloud software engineering agent running in isolated PaaS environments. Anthropic documents computer use and code execution. It also documents Claude code permissions and sandboxed command surfaces. Cursor has publicly described rolling out agent sandboxing for local coding agents, and NemoClaw points the same direction in a different way. It takes an OpenClaw-style assistant and wraps it with sandboxing and policy. It adds credential separation and lifecycle controls around the run. The specifics of each one are different, and I don't want to mush them together. A hosted code interpreter is not a local process sandbox. An open shell wrapper is not a browser session. A dev container is not an MCP gateway. They live in different layers of the stack, but the direction is consistent. Once agents can touch real state, serious products start building boundaries around the agent, not just better prompts inside it. The model isn't the whole product anymore. The environment around the model is becoming the product. The reason this is happening now is pretty simple. Useful agents need access. A coding agent needs a repo and a shell. A browser agent needs a session with real pages and cookies and accounts. A back office agent might need documents and SaaS tools and private data. Strip all of that away and the agent is harmless, but also useless. Give it everything and it's powerful, but dangerous. The controlled environment is basically the negotiation between those two failure modes. That's why the better examples aren't just agent in Docker. They're bundles of product decisions sitting on top of the container. A clean workspace instead of your whole machine. Scoped file mounts instead of every folder you've ever touched. Network rules instead of open egress. Temporary credentials instead of permanent secrets. Diffs instead of invisible edits. And human approval, but only at the points where the agent is actually crossing into higher value state. Those aren't enterprise checkboxes. For a builder, they decide whether the agent can be trusted with useful work at all. For a buyer, they're the difference between a clever demo and a workflow you can actually deploy. For a security team, they're where the abstract AI risk conversation finally turns into something inspectable. Which action was attempted? Which boundary stopped it? Which permission allowed it? What changed after the run? There's one security idea here that's worth slowing down for. The risk isn't simply that a model sees a weird sentence. Models see weird sentences all day. The risk is what that sentence is sitting next to. A useful frame comes from Simon Willison, a longtime developer and AI security writer who also coined the term prompt injection. He calls this pattern the lethal trifecta: private data, untrusted content, and a way for the system to communicate back out. That frame is useful because it moves the conversation away from vague AI fear and toward the actual system shape. Picture a browser agent reading a page while it is also logged into your accounts. Or a coding agent reading a GitHub issue while it can see your repo and run tools. The page or issue may be untrusted. The private data may already be in context, and the tool channel gives the instruction somewhere to go. At that point, the attack surface is no longer just the prompt. It's the path from what the agent reads to what it can do. You see the same concern show up in Agent Dojo, which is basically a research benchmark for testing prompt injection attacks against tool-using agents. The point of Agent Dojo is not, look, prompts are scary. The point is, what happens when an agent is doing realistic tasks, using tools, and reading data that might contain hostile instructions? MCP tool poisoning work points at the same deeper problem, but from the tool side. Once agents use tools, the tool boundary becomes a trust boundary. A credential becomes capability. A browser session becomes an account surface. A tool description can quietly shape what the agent thinks the tool is for. And a GitHub issue is not just a task anymore. In the wrong setup, it's untrusted input sitting beside a repo and a shell. So yes, sandboxes matter. But I want to land the caveat early because it's the thing that keeps this video honest. A sandbox does not make an agent trustworthy. What it does is shrink and record the blast radius. That's it. If the agent has legitimate network access, it can still leak through legitimate network access. If it's got a real production API key, it can still mutate production through that API. Moltbook is one useful receipt here. The failure pattern there was weak platform and app controls. The blast radius material ended up being API tokens, emails, private messages, and credentials. Things people don't normally think of as one incident's worth of exposure. So the direction isn't one sandbox fixed it. The direction is that more sandboxing and policy is being built around agents because the old loose version starts to look too risky for serious workflows. And even then, things can still happen through allowed paths, through real credentials, through public actions the agent is permitted to take, through weak app controls, through sloppy lifecycle boundaries. If an agent can send email, some actions just aren't meaningfully reversible. Same if it can post publicly. Same if it can purchase, deploy, merge, or delete. If logs capture secrets, your audit trail becomes another sensitive data store. And if every risky step turns into a confirmation dialog, users learn to click through approvals the same way they click through every other warning. That's why I don't love sandbox as the headline word, even though it's useful. Sandbox sounds like one box. The actual thing is more like a controlled workbench for the agent. It needs a place to run, a narrow set of files, credentials that expire or can be revoked, network access that starts closed, and commands that are separated into safe, risky, and absolutely not without a human. Not every step needs a permission pop-up, but when the agent is about to cross a real risk line, the product should show the exact action, not another vague approval screen. The other half is memory. Not model memory, operational memory. What prompt came in? Which tool got called? Which browser page changed? What diff was made? Which approval happened? Which network call failed? Once an agent does something, was the answer good? Is almost the wrong first question. The useful question is, can I reconstruct what happened without guessing? That flips normal software instincts. Logs, diffs, staging, rollback, permission prompts. In ordinary apps, they feel like drag. With agents, they make delegation possible. Too much approval, and the product becomes unusable. Too little boundary, and you don't have an assistant. You have a tiny intern with root access and a lot of confidence. So the target is not maximum autonomy. It's autonomy that changes with risk. Let safe work move quickly. Slow down when the agent is about to touch money, accounts, production, public actions, or private data. And this is why sandboxing is old misses the point. Of course it's old. Containers are old. Least privilege is old. Audit logs are old. The new part is where they sit. They move out of the backend checklist and into the trust layer of the agent product. Before you let a probabilistic worker touch real systems, you need to know where it can move, what it can reach, and how cleanly you can unwind things when it gets something wrong. So if you're building or buying an agent product, I wouldn't start with how smart is the model. I'd start with the operating boundary, where it runs, what it can reach, what trail it leaves behind, and how you get back to a safe state when it makes a mess. That pulls the conversation away from the demo and toward the unglamorous stuff underneath it. Because trust comes from knowing the agent is working inside a boundary you can see, limit, and recover from when something goes wrong. The platform that wins here may not be the one with the flashiest autonomous demo. It may be the one that treats the model like an untrusted worker from day one, so its work is bounded, inspectable, and recoverable. That's why agents now need sandboxes. More precisely, they need the controlled environment around the sandbox. Once software starts acting on your behalf, the boundary is no longer background security plumbing. Without that boundary, you're not deploying an assistant. You're allowing real systems to reach the worst-case scenario at machine speed. If you like this video, tell me what you think. Like and subscribe and show your support. More of this is coming. Peace.